How is it that we see? How is it that we move? What can we learn from biology? And how can we then use that to create the next generation of robots? So I'm Laurent Itier, and I'm a professor at the University of Southern California, and we try to understand how the brain works and how can we emulate that and build machines that would have the same capabilities. We do a little bit of everything. We look at how can we develop new kinds of software, new kinds of mathematical proofs, new kinds of algorithms that will basically replicate the kind of behavior that we find in the animals. So in my lab, we are mostly interested in vision and attention. Observing eye movements of people is like having a little window onto their mind. In our lab, we are really trying to push eye tracking by having people look at very complex scenery. For example, some footage from Star Trek.
We're conducting an eye tracking experiment here where we have an infrared camera that is shining an infrared light at his eyes so we can see where his eyes are going as he watches this movie. And then we can later use these eye tracking positions that we've recorded using this camera to make some inference about what's going on in his brain.
Why?
Because the captains have to concentrate on piloting the vehicle.
Why?
Because
Data!
Sorry, sir.
There is some computation that happens in your brain which is very sophisticated and very non-trivial that eventually gives rise to the decision, oh, now I'm going to look there. And so we are actually quite close to replicating this. However, there is still a lot that we really don't understand. For example, understanding the kind of objects that may be present in a scene. And I believe that this is the next frontier for robots. This is really what we are missing. So this is what we are focusing on in the lab.
Strange is not a sufficient adjective to describe the experience. I am slightly interested.
One of the most challenging problems that we have is in perception, and how is it that we actually look at particular objects and be able to understand what it is that we are looking at. What we have here is basically a model of what a human would be able to look at. And you can see here what's happening. This is called a saliency map, and that's showing the interesting things in the scene right now. The next step from here is to actually completely recognize the object. So this is more of the detection, knowing that there are objects around. The next stage is to completely recognize the object under various conditions, if the lights are off, on, and then be able to perform some tasks with them. So it will utter responses based on how interesting that particular location is or that particular, object is.
If you think this thing is salient, you must be joking. Sensors show no intelligent life form of any kind. Excuse me, what does it feel like when a person is losing his mind?
The future of robots is what was promised. At some point, we need to have those cars that will drive on their own and those personal assistants. So the future of robots is exactly what we learned from sci-fi. It will happen in this way.
Would you like me to drive, sir?
We need to just really figure out the sensory and motor components for those robots to exist.